I want you to understand what I am saying very well. There are two types of circuits in an AC. We have a circuit where only inductor or only capacitor or both of them are used to regulate current. Okay, that one is called reactance. So it is either only capacitor is used or only inductor is used or both of them are what? Used. That situation in AC is called reactance. Now when the three of them, because resistor is the one that does the work of regulation, but in AC circuit, the three of them do the work of regulation. That's the difference between DC and AC. Normal capacitor store charge normally. Inductor produces electricity by bringing two conductors very close. That's his work. While resistor regulates what? Charge. Now, that is, but in AC, capacitor will not work, will not do the work of storing charge anymore. Inductor too will ignore its own function. The two of them will now join resistor in doing the work of what? Regulation. That's what I want you to understand. So when the three of them are doing the work of regulation, it is called impedance. That is impedance. What is impedance? Impedance is overall regulation to an AC circuit. Overall now, because the three of them are doing it, that's why I say overall. Overall regulation offered to an AC circuit. But what offer it? Offered by resistor, inductor, and capacitor, the three. Or resistor and any one of them. Can be resistor and inductor, or resistor and capacitor, or resistor with both of them. Now, but if resistor is not in the circuit, either capacitor is doing the work of regulation, or inductor is doing it, or they are both doing it. That one is called reactance. So that is what I want you to understand. I can put more light on that AC circuit. That is if you want me to. That is the end of it. So I have some formula which we need to also note for impedance. Now, if I have only capacitor and inductor, which is called reactance, so the formula then, I can have it as square root of, let's say, capacitor, okay, then, so this is called inductive reactance, sorry, this is called capacitive reactance, and this is called inductive reactance. Then, now, but this happens in reactance. But if it is impedance, we use letter Z to know the overall regulation. So overall regulation is main resistor. When both capacitor and inductor are used, then the regulation, both of them will supply. R for regulation or resistor, you can get it through this formula. Square of capacitive reactance, so the square root of the square of capacitive reactance plus square of the inductive reactance. But if it is the three of them that do the work of regulation, we call it impedance, and this is symbol. So we can have the overall regulation as R squared plus, you now open bracket. Okay, let's do it like this. Subtract inductive reactance from capacitive reactance, or anyone that is big. Of course, this is not constant. If it is inductive reactance that is bigger, meaning you are subtracting. But even if you get negative here, when you square it, it later changes towards positive. So don't mind. You can put this one here, you can put this one, you can put it anyhow. So answer here, square it plus square of this answer. That is what the value of impedance. So that's the end of our discussion. Now, so let's see how we can use any of the formula I have on the board to solve one or two questions. Two parallel plates of potential, meaning one of the plates has potential of 100 volts and the other one 0 volts. separated by meaning distance between the two plates is 0.1 meter. The question now says find the potential V. Find the what? Potential V. I can try this. Find the potential V, or I try this. So any of the two that goes. So you have once asked me that how will you identify the formula you can use? You won't be able to identify any formula in physics if you have not mastered so many formulae. That's what you do. So the first thing you do is that when you see the question, look at all the parameters in the question, write them out. Parameter means all the information discussed in the question, write them out. Now from your head, think of any formula that has everything in the question except only one thing. So why am I going for this or this now is because they say find potential V. And on the board I know that it is either I use this or I what? Use this. So which one am I picking? Depends on the information. Now the information here has distance and have V, but here you can see charge. So and there's nothing like charge here. It shows that this is the one I can what? I can use. So that is how we choose a suitable formula in physics. So let's try this now. Let's try this. Let's try this. So where can let me come here now. Okay. I think we have noted this. Please note it because I want to clean it. Note this very well. This is the regulation in a circuit when only capacitive reactant and inductive reactant are used. And this is the overall regulation when the three of them are used. Okay, so I am using this now. V is equals to E what? D. This is distance. And this is what? Electric what? Electric field intensity. So I can decide to find this equals to V over what? D. And then I have V on the board. 100 minus what? 0. That is change in V. Don't forget. Then over what is our distance? 0.1. Please take this calculation. The calculator. So I want to clean here as well. So what am I looking for now? I am looking for electric field. Though electric field is not what they want us to find. But let me get it back there, put it back in this formula to get my V. Meaning, so I'll be having E is equals to 100 minus 0, that is 800 divided by 0.1. So I have 100 divided by 0.1. So I think I have here as 1000 if I am right. So this one is in voltage, this one is in what? Meter. I can say V per what? Meter. Now that I know this, I can put it in. So I want to know our V now. When distance has moved from 0.1 now to, so this is our V when distance is just 0.1. But now that distance is no more 0.1, it is now 3 centimeters. Calculate new V, that's what the question says. So these are the voltage or potential when the distance is what? 0.1. So calculate the new potential when the distance becomes 3 centimeters. That's exactly. So the new potential now when distance becomes 3 centimeters is going to be V equals to E, which we have got it to be what? 1000 times D. And what is D? That's 3 centimeters. 3 centimeters is the same thing as 0.03. What have I done? I divide by 100. I divide by 100 to convert it to meter from a centimeter. So let us see the new voltage when the distance becomes 3 centimeters. So times 0.03. So I have 32. So that is how we handle something like that. When it is 8 up to 9, let me do 8 minutes to 9. So that is how we get that. So I will solve this. Then this one you can try it and let me have your response. So number 2, if potential V in a region is 5s squared volt, now find E. Okay, find E. Find E. Find E. Okay, find E. Now, there is A here and there is A here. So, which means I can either use this or use this. So, but Because this thing is given in terms of variable, I think it is very simple or easy for me to use this. I can use this, very simple, and I can use this. But we are looking at the question. The V you are given is given in terms of what? Variable. You can see X. So that is what will nullify this. If it was given as ordinary number, I would have gone for this, because I have V and I have distance. So I can get my what? E. But because our V was not given as ordinary number, it was given as a what? Variable. It will be very easy for us to use to differentiate it, because this is symbol for what? Differentiation. That's exactly what I am going to do now. So using E, which is equals to minus the V, the what? The X. Now, meaning we have to differentiate our V. This is V. So the V means differentiating, and we are very close to differentiation. E is equals to, how do we differentiate? General formula. 2 times 5, that's 10. So I have 10, then X, 2 minus 1. So meaning you are subtracting 1 from the power after you have multiplied that power by the what? Coefficient. So I'll be having our E equals to minus 10 minus 10x. But now we say at x equals to what? Equals to 2 meters. So our E is equals to minus 10 bracket 2, and that is minus 20. Let's look at the unit. The unit can be voltage over, so I have V per meter. I derive the unit here. By the time you divide by D to make E the subject, I'll be having E equals to V over D. So unit for V is, and then that of distance is what? Meter. So this is where we are going to stop.